Hello, so today we'll be solving the circuits problem and we're asked to find the current through the 15 ohm resistor. So we'll label this I, and then we'll find the potential difference between points A and B. So first of all, I want to pick where my ground is. For this problem, I think node A would be a good spot. And then we'll be doing nodal to find the voltages at each point. And we're going to add a point up here called C, just because we know by inspection that VB minus 25 volts equals VC, and this will help us out later because we have that voltage source up here. So for nodal, aka KCL, we're going to be doing node A. And then the way I do this is everything going into the point, all the currents are negative and all the ones going out are positive. So for this one, we will make our way around. So this current right here, we'll be doing VA minus VB. And then because the 10 ohm and 15 ohm resistor right here are in series, we can just add them. 50 ohm, and then the next one I'll start up here and then I'll go down each branch. So then we have VA minus VC over 10 ohms, and then VA minus VB over 10 ohms, and then VA minus VB over 5 ohms, and then we set that equal to 0. And then we know, because we set A to ground over here, we know that all the VAs will become 0. So I can rewrite that. So negative VB over 25 ohms, negative VC over 10 ohms, minus VB over 10 ohms, minus VB over 5 ohms equals 0. And then the way I do this, I like to clear out the denominator. So if we multiply all of these by 25, we'll get negative VB minus 2.5 VC minus 2.5 VB minus 5 VB equals 0. And then next, we just want to condense. So then we end up with negative 2.5 VC minus 8.5 VB equals 0. And so now we have our two equations. So over here, we have this equation that we just made, and then we have our equation over here, which can also be rewritten as VB minus VC equals 25 volts. So with this, we can make a matrix to put into our calculator. So we have VB, VC, and then we'll have our constants over here. So it'll be 1, negative 1, 25. And then we'll have negative 8.5, negative 2.5, and 0. Since this column right here is all the VBs, and then this is all VCs. And then you'll do reduced row echelon form in your calculator, and then what you'll get is VB equals 5.68 volts and VC equals negative 19.32 volts. And so we know number 2 now, which is the potential difference between VA and VB, what we found in our calculator, and we know that the difference will be VB minus VA, and then we know that VB equals 5.68 volts and VA equals 0 volts. So then what you get is the potential difference is 5.68 volts. So here's the answer to number 2. And then the answer to number 1 is find the current between the 15 ohm resistor. So that'll be between points VB and VA. So here, since we have the current going this direction, we'll write that as VB minus VA over 10 plus 15 ohms. and then you'll get 5.68 volts, and then VA0 over 25 ohms. And then what you'll get from that is 0.227 amps. So this will be the current that we found, and we'll notice that it is a positive answer, which means that we guessed the current direction correctly. So that's how you solve this problem, and I hope it helped.